Sherlock Holmes and Dr. Watson went on a camping trip. As they lay down for the night, Holmes said, "Watson, look up in the sky and tell me what you see." Watson replied, "I see millions and millions of stars." Holmes said, "What does that tell you?" Watson said, "Astronomically, it tells me that there are millions of galaxies and potentially billions of planets. Meteorologically, it tells me that we will have a beautiful day tomorrow. What does it tell you?" Holmes replied, "It tells me someone stole our tent." So we are going on reasoning in this unit. We'll be looking at both inductive and deductive reasoning. And Holmes is actually known more for deductive. But today we're going to start with inductive reasoning, which is finding patterns and making generalizations based on those patterns, which is not necessarily a bad thing. And also being able to prove things are false using inductive reasoning by finding counterexamples. So what is inductive reasoning? It's the process of reasoning that a rule or statement is true because specific cases or examples are true. So for anything that we're looking, a lot of the things we look at in science today, whether it's the climate or the migration pattern for whales, those are based on inductive reasoning, where we make observation, and based on those observations, we're going to make a prediction. So inductive reasoning is based on observation. So one of the things when we do inductive reasoning, we make our observations, and then based on our observations, we're going to make something called a conjecture. A conjecture is a statement that you believe to be true based on your observation. Now, you can make a bunch of observations. For example, I could make the observation that all birds fly. And all the birds I've seen around my neighborhood have a fly. Although, if you go just outside of my neighborhood, we actually used to have some ostriches around here. And if you show me the ostrich, you could say, well, that bird doesn't fly. And that will be a counterexample. So conjectures can be true or false. And a counterexample is a specific case that shows a conjecture is false. So in this case, my counterexample would be the ostrich. The conjecture would have been that birds fly. Here's one of my favorite conjectures. Students who do their homework will get better grades. I think this conjecture is true. All right, so how do we come up with a conjecture? So first of all, step one, we look for a pattern. That means go ahead and list at least 3 examples. And if using numbers, try setting up a table. Also, drawing a picture can be quite helpful. Then you're going to make a conjecture based on the pattern. What do you think is true based on it? And then you're going to test the conjecture by looking for a counterexample. If using numbers, try more than one type of number, such as a whole number, a fraction, a negative number, or 0. Also try drawing a picture. You only need one counterexample to prove a conjecture false. So to prove that not all birds fly, all you have to do is tell me about the ostrich. You don't have to tell me about the penguin. Here's an example. Determine if the following conjecture is true or false. If 2 angles in a triangle are complementary, then the triangle is a right triangle. Well, I'm just going to try by looking at examples, at cases of triangles. So I'm using inductive reasoning, looking to see if there's a pattern. So the first triangle I'm going to draw is a 45 degree in one angle. And if the 2 angles are complementary, that means the other angle has to add up to 90, so that has to be 45. Well, if it's a triangle, that means that other angle is going to be 90 degrees. Okay, so that one is a right triangle. Let me try to change it up. I'll make one angle 30, which means now if they're complementary, remember that means they have to add up to 90 degrees. The other angle has to be 60. Oh, that has to be a 90 degree angle too. And let me try again. 10 degree angle up on top here. Can't even fit it in there. 80 degree angle on the bottom. Oh, this has to be 90 as well. Just based on my observation, which is inductive reasoning, I am saying that this statement is true. I can actually later prove this with deductive reasoning, but we'll get to that later. Here's another example. Determine if the following conjecture is true or false. The sum of an acute angle and an obtuse angle is 180 degrees. So you can come up with an example where it's true, So 70 is your acute angle and 110 is the obtuse angle. That's 180. Sure, that one works. That would be true for these two angles. But if I change it up just a little bit, 60 is my acute angle and 100 is my obtuse angle, then I don't get 180 degrees. This is called my counterexample, and my statement is false. So for this section, if a conjecture is sometimes true, then what do you think is its truth value? A conjecture, if we can come up with one counterexample, that means it's sometimes true. But for conjectures, we have to say whether it's always true, or if it's not always true, it's considered false. Only when we ask you sometimes, always, never, do you get to differentiate between never true and sometimes true. Where sometimes true is its own category. If it's only sometimes in logic, it is considered false. What is a counterexample and how do we use them? And what are some strategies to test if conjecture is true or false?